name is Didier Barradas Bautista, along with my mentor, Mohsin Shaik. We're going to disclose some secrets about how to use Shaheen and Ibex here in the university. So you might be aware of our mission of the KSL. We are an integral part of Core Labs. And of course, we want to provide you the best service we can to help you to do your research with compute hours and, of course, some computing tricks. Okay. So for the agenda today, we're going to be over a quick overview. You're going to meet Slorm, which is going to be your best friend from now on. And then we're going to have a break. We will try to run some IDEs, which is Jupyter notebooks, well, Jupyter Lab, Code Server, which is becoming famous because it's the free version of VS Code. And then if we have more time, we will see more things about containers. There's going to be a special session for containers. So if you're interested, and you should be, please sign up and come to the workshop. It's going to be very interesting. And some other demos about containers and how to scale using these containers. Okay, for documentation and support, we have several resources. One that I want you to check out is the last link, the GitHub link, because there you will find in the README page, in the first page, all these links and some more, because we have, for example, also YouTube channels with many other explanations. We're going to put some recordings there, like this one, we could. And of course, if you have not joined the KAUST Ibex Slack channel, please join. It's just a nice library of different questions already answered. Pretty much many of the questions you might have, you can find them there. There is documentation in websites, like you see. And the first two links are actually trainings that we KSL provide for Shaheen and Ibex. There are schedules and there are also recordings and slides and so on and so forth. Okay, let's start with the platforms. If you don't know, we have a very nice and big machine called Shaheen. Shaheen basically is all CPU. However, it has a very high performance architecture. It's really, really, really fast. When I mean it. We have about 6,174 nodes for you to use, which have, you can see, almost 200,000 different nodes. So if you can run your jobs in a parallel manner, they run like super fast. That is ate up also with the connection that they have, the network that is called Dragonfly. It will it will provide you with a speed that is unheard of on your desktop or your laptop. So also Shaheen have some file systems that you should be aware of. You have your home, you have your Scratch, your projects, and something that's called burst buffer. To those of you that attended to the Shaheen 101, you are familiar with this terminology. Your home is something that is very small. Basically, you're logging into it, and you should have nothing but very essential things. You can compile stuff there, but you cannot run jobs in your login node. Please do not run jobs in the login node. So Scratch, on the other side, is a partition that is going to be super connected. That's where you have to run your jobs. And that's the high performance part of the supercomputing. Now, you also have something that is called projects, where you can store different information. You can put, for example, your code environments or whatever is going to be safe there, because as you can see, we have also how it's called, the persistence. That means that it could be deleted or not. Anyway, so projects is going to be something that you can use to store some things safely. And then the burst buffer is something that you have to ask for it. If you have like a very intensive IO procedure, then you can apply for it. You have to write a ticket and let us know, hey, I need this thing because I need to run faster. Okay, so be aware of two things. Scratch doesn't have a backup and is purged every 60 days. So if you don't touch anything during 60 days, it gets deleted. And we have heard about so many users losing data this way. So please, one, do the backup. I know you don't like it, but do the backup. And be aware of this purging day, because many people goes to vacation, come back, and there is no data there. Okay. So moving on. Apart from Shaheen, we have another thing that is called Ibex. Now, Ibex is composed of different parts. It's not a homogeneous thing, so you have different things. You can see the main things here. We have large memory nodes. We have Intel nodes, GPU nodes, AMD nodes that are connected very tightly. And we have a local space. So this is one of the stories, because we have a CPU partition for Ibex. This partition consists in basically Intel or AMD nodes. You have two specific ones that are large memory, which are the Skylake and the Cascade Lake from Intel. If you need like a very hungry memory procedure, these are your choices. Hopefully you don't need to use them because there are very few. But then we have much more nodes, CPU nodes that you're familiar with, your computers have them, and so on and so forth, that are Intel and AMD. And you can see that they have different configurations about memory. You can max out some, and depending on your request, you will have a type or the other. Okay, now, the sexy part of Ibex is that it has GPUs. So these GPUs have come in waves during the story of Ibex. So you can see that we have still Pascal GPUs. They are still useful, don't forget it. You have GTX that are, okay, a little bit old, I know, but they still work very well. Then you have the B100s, and lately we have also added A100s, which are the lastest of the GPUs that NVIDIA provides. They are super good for matrix multiplications in case you need to like run something like that very quickly. A100 could be a good choice. And of course, you can see that some of them have NVLink, which is something that could accelerate your training of machine learning stuff, but it's something that interconnect the GPUs and CPUs more easily and runs faster your programs. Now, just like Shaheen, Ibex also has file systems. You have home that is actually shared with Shaheen, but don't get me wrong, there are two different things. It's going, if you log into Shaheen, it's not the same as logging into Ibex. Now, the thing with home is the same. You have very short amount of memory there to store stuff. Do not use it to put datasets there. Do not use it to run HPC things, because you're going to affect everybody else, okay? Maybe you do it without knowing, can happen. I've been there, but please do not use the login node to run stuff, especially in parallel way. You have Scratch. Then Scratch, just like in Shaheen, you can run your workloads there. It's going to be highly connected. It's going to be fast. We have now rolled out Weka IO, which is something that is new. We can talk about it a little bit later. And of course, you have something that is called local storage, which is something that you can use, but once your work is done, all data in that storage is gone. So it just lives through the life of the job itself. Okay. So what else? Okay. We can do a local storage demo about that. Okay. Yeah.
Ali.
Okay.
Login as me. Right.
Okay.
Thank you. Hi all. Mohsin Shaik here. I'll do a short demo of what does local storage non-persistence persistence mean. That what happens to your data basically. So let me log into Ibex first. So Didier is going to talk about this part soon. So can people see the, okay, yeah. All right. And in short while, you will be cloning this repository in your Ibex directories as well. So you'll get all this. So what's the idea? The idea is that this is a job script, and this job script, and don't worry about what a job script basically is. It's a way to talk to the Slurm scheduler. We will talk about it in detail. So the crux of the matter is I'm trying to take some data from, let's say, home or Scratch, which is shared file system, and put it on a local storage disk that is on the node. So you got the allocation of the node, you have some SSD attached to it, which basically gives you very close proximity to your data when you're computing. And the idea is that you have a directory called local storage there. And basically what you want is you copy that data, and then in the Python script, you want to access that. But then you use the Slurm launcher, srun, which may be used to actually run something that is parallel to pin on multiple cores. And you do the same thing. You run the same Python script in that. What does that Python script do? Well, that Python script is fairly straightforward. It actually lists the directory that you just copied. Okay, what files are there? Okay, there's nothing complex happening there. So let's try and submit this job. Let's see what happens. Okay, it's about to start. Okay, it had started, and there's a output file from Slurm showing me some output. So it says, howdy, from this GPU node that I went to, where is the data set? The data set is here. I just copied it to /local. /local means now it's on the disk, right, that I was talking about. And then basically it queries that data, that Python script that I talked about. So this Python script that I talked about, that queries what data is there, and it shows me some directories. It's a CFAR10 data set. And then if I look at the last bit, basically now checking if the Python script can access it. So basically it did, but the last bit did not run. It's okay, it's sleeping for 3 minutes. 3 minutes will be up soon. I'm waiting for the output. Let's see how it goes. Well, usually I'm a bit jittery with the live demos, but the intent is this srun will not be able to find it, right? And the reasons for that are that when srun runs, and I'll talk a little bit about this in detail in the latter part, it actually encapsulates your resource that nobody else can touch it, including the disk space, right? And there, the data doesn't exist. So the alternative way of doing it is, okay, let's forget about that one. The alternative way of doing this is basically run this script. Now, this script, this is a Python script again. And what it does is simply copies the data, not in the bash script, but inside the Python script itself, right? So you can do that with the OS package, right? It's a pretty straightforward, exactly the same way you do it, but as a OS.system. command, right? So what you're doing here is a few lines with os.system, calling the cp command, take it from the shared file, a directory called /scratch or something to my /local/storage in the destination space, and then query it. And this will finish hopefully in time. Okay, let's see if we had this. Okay, yeah. So you see in the previous job, the last step did not run successfully because it did not find that data set that it was looking for. Let's see the, okay, so this one has finished. The second job, did we submit it? Let's submit it again. Okay, it's running. 1997 is the job ID. And as you see, there is no issue here. The srun command, the Python script invoked by the srun command can now find the data on the local storage that you were supposed to use. And the local storage would be used when you need high IOPS. IOPS means reading, writing the data, closing the files, opening the files very, very randomly and quickly. So you have very small files, but millions of them. And surprise, surprise, the image data sets, computer vision data sets have those kind of things, right? So, yeah.
All right. Okay, back to this thingy. All right. So this was basically a very quick overview. So if you want to use Ibex or Shaheen, there are two different, computers. They have different kinds of access. If you are here in KAUST and you have IT credentials, you can use Ibex by default. Just have to tell the guys from IT to just activate your credentials, and that's it. For Shaheen, it's a different thing. Shaheen also provides services to people outside of KAUST. So for that, you need to submit a project proposal. It could be a developmental project or a production project. I think in Shaheen 101, they explain more in detail what is this. You can check it out also in the links that I provide. And then you have to apply. Once you get a certain amount of hours granted, you can use Shaheen for as long as you have core hours inside. Okay. Now, let's talk about something that I want to emphasize. This is a very generic view of what is a high-performance computing cluster, right? You have a login node, which is the terminal thing that you see there, that is connected to the yellow screen there. Now, what happens often is that newcomers doesn't know this, so they try to run things in the login. The HPC clusters usually have a part that is the storage connected to the compute nodes, which is the actual supercomputer part. These two parts are highly connected. They have special things linking each other. So this is why whenever you see somebody who is new here at KAUST, please tell him not to run things in the login node. Why? Because we have usually complaints about the performance in the login node. When you use htop, for example, it will tell you what is running in the login nodes that you are. What you see on the top is the worst thing that can happen, which is overloading the login node. That means that even basic commands from your shell is not going to work. Your ls, your list of files, is going to take forever because somebody is using every resource in the login node. That's not HPC. That's not even the supercomputer. It's the login node. You're supposed to enter there, double around, save some things. And if you want to really work on something, then you ask for resources. Okay. This is why, again, no data sets here, because you have a very small amount of data that you can do there, 200 gigs. And it's very slow connected. This is not a supercomputer. It's just meant for you to communicate with it. Okay. So let's start with the exercises. Any newcomer to KAUST has this problem. There are two ways to log in to Ibex. And it's because we have two different login nodes, one for GPUs and one for CPUs. So please try this one. Try the G login node in case you have already access to Ibex. So fire up your terminals, and then you just put, for example, who am I? If you don't know who are you, then you can advert this identity. Okay.
Everyone is KAUST here?
No. Okay. For those that are not KAUST, you probably can if you charger. Okay. Okay. So there are other kinds of users, which is the Shaheen users. So for this one, you need to log in into Shaheen, which is a different kind. Okay. Now for the Shaheen users, I do want them to do something different. Yep, sure. So you saw Mohsin doing that actually here. Let's repeat it. If you do your SSH, your user, in my case is Barradas. You can use glogin.kaust.edu.sa. You will be prompt. Hey, what's up? glogin.ibex. I forgot. Because I'm trying to log in into Ibex. Then you get prompt to put your password. This is your IT password. And then you have this thing here that already told you you are logging in. You are in the login node. For Shaheen users, almost the same thing. Epa. But you have to, instead of Shaheen, use this one. SSH, your user at shaheenhpc.kaust.edu.sa. You will be prompt to put your password, but also you need a one-time password that you should have in another device, by the way. Let's put mine to the work. And you are logging when you see this guy here. Okay, so in that case, I am in this login node for Ibex, and this is my login node for Shaheen. You can see you're in the login node because it basically changes your default in your terminal to this CLD, or this is my machine, and now I am in the login node. All right. Now, if you don't know who you are, who am I? Who am I? This is my user. Framework in directory. I am in home. You can do exactly the same here. And it should tell you exactly the same thing. For both Shaheen and Ibex, they have basically the same login node. Okay, now let's do something a little bit more complicated. If you can, please go either to your Scratch directory. Well, specifically for those of you that are Shaheen users, they have to go to the projects. They have a project assigned, usually starting with K and then 4 numbers, and then user. For those of you that are Ibex users, go to Scratch. It would be this thing. Whoop. cd ibex scratch user. You should go into this directory. It will appear with your user. Then let's try to git clone this repository here.
So if you can't see it there clearly, easier way would be go to GitHub and find KAUST minus RCCL on the whole GitHub, and you will find us there.
Yeah, here it is.
Okay.
KAUST RCCL data science onboarding.
KAUST-RCCL.
Okay. You will find this repository here. Like I said, in the bottom, you will see different links.
Has everyone got the repository for the code?
Everybody cool? You can always copy here. And then do git clone. And this will start downloading this repository in your Scratch or in your project. Again, for Shaheen users, go to your project directory. Your Scratch is going to be a different thing. Go to project. Okay. From project, we're going to run.
Submit from project directory?
No, Scratch. Yeah.
So everyone has Ibex HPC, right?
Okay. If you already cloned your GitHub repository there, then you can go into install Miniconda, Shaheen, for example. And you can run install Miniconda there. This is kind of generic because it should work also for Ibex. But for Ibex also we have special recipes. But for now, you can do this. And then just let it run. It should be in red, for example. So I actually have that here because you should have something like this in that directory with all these things. Hmm? You can do it. Yeah, go to Scratch because you will have more space in Scratch. So you can do cd Ibex Scratch your user. You can do that. You can write your username. Uh-huh. Oh, don't worry. You find yourself. This is a self-improvement group. Excellent. You know who you are, and you can find yourself here. Amazing. Okay. Anyway, so if you go here, so you can see install Miniconda here. This recipe here. Let's go over here. This is better, I think. Yes. So this recipe here allows you to install something that's called Miniconda that will allow you also to create Conda environments, which are in itself contain environments where you can work with Python and other things like R, Julia, other programming languages.
So for those who have Miniconda or Miniconda installed in their environments, in their directory, you can use your own as well. You don't have to do it again.
Yeah.
Right?
Yeah.
For those who are new to this, you can follow this script.
So if you arrive to this part, you already find yourself, you know who you are, you have Git clone stuff. I think you successfully went over the first examples. All right. So there is some other things inside Ibex, for example, like we have reference folders. Sometimes when you're doing machine learning training, you have some data sets that are reference for everyone. You can find them here in this folder, Ibex reference. But it's something you might use, you might not. However, the other partitions, you will find them. Like, for example, the home, the scratch, the project, they are pretty much the same name across the two different computers. What is different, for example, is like in Ibex, we have something that's called fast scratch that is similar to the burst buffer. But okay, this is, so you see that details are actually shared between the two supercomputers. So it's not confusing. We're not naming different things in a different way. All right. So I told you about Slurm, your new friend. Slurm is something that is using HPC. HPC, what should I say? Institutes. So across the different institutes, they use different schedulers. What does mean? How do you talk to the machine to ask for something? So Slurm is a resource manager. Basically, you have to know how to use it in order to describe what you want. And then you use a job script to submit your requirements. Now, in order to know what you want, you also have to know how to ask for it and what you have inside. So why don't you typeginfo for those of you that enter the G login node? You should see some table like this. Is that correct? So as a matter of fact, you should have the newest version of this one with A100s, I think. If you see, there is a difference between this one, which was previous to that one. But then you can see also what's going on with the different nodes. There are some nodes that are idle. There are others that are drained. When they are drained, you cannot use them. If you find your node to be drained, then raise a ticket for us, talk to us through the Slack channel, so the systems administrator team can actually undrain it, and it will be back into production again. Okay. Now, something that is also part of the scheduler system is the SQ command. You saw Mohsin actually use it. It's something that will tell you, is my job running, or who is running what job? And now you cannot kill another user's job. I have heard that before. You can actually query the system and see, okay, let's do that. If you go here and you use SQ, it will give you everybody's job. If you do S user.
So very funny thing is happening right now. It's the G login node has, if you can run HCOP on it, you will know what bad stuff is happening here. It's full right now. Somebody is killing it, and you might actually see degradation. Yeah, the swap memory is swamped. Yeah. Okay, but this is. Thanks. Oh yes, there are people who can go to their homes and knock the door. So here in Ibex, you can do sq-me, for example, just to see what are you running, or you can use -u and then your username. I will use just this one. So I have no job running, correct? So nothing appears. If I ask for something, okay, I will ask for that later. Okay, let's go back to here. And okay,
So SQ can work with different things like -u username to show your jobs, -p if you have some kind of partition that you are working on, a specific project, or -j job ID if you want to see a particular job that you just submitted, and it's like, how is my job going on, or how much is it running, or time, and so on. Okay. Usually when you have SQ, you have these, you have the different names of the user. ST is the status. You will see R if it's running, PD if it's pending, and so on and so forth. Don't get scared if you just see something that you don't recognize. You can always search for it in the internet. But anyway, so you can also use sinfo in any general system. Shaheen users can also use it. sinfo -ne -o &n &n. Try this one, for example.
This is for so, and Didier very aptly mentioned that Ibex, as opposed to Shaheen, is not a homogeneous system. It has a lot of resources of a lot of types. So if you want to query how many resources are there which are tagged as V100, right? Which basically means Volta, GPU, NVIDIA V100, right? If you wanted that, how would you tell the scheduler what to add, what tag to add, what feature or constraint to add? This is how you know, okay? This is how you know how many GPUs are there with that tag. And -o %n, %f is formatting that list that it is going to spell out. And the first bit will be the node ID for the machine name, comma, which features will you be able to add in your job script to get that node, right? So that's a constraint to put on your job request.
Okay. Exactly. Talking about restrictions, constraints. Okay. You have different things that you can tell the Slurm, like I want this for how many time, for how much memory. As you saw in the previous slides, you can have access to different kinds of different amounts of memory. So in that part, you have to make basically in a batch script what you want. You have to submit it, and when it runs, could run for several hours. But we have two modes. Okay, we have the interactive mode, which is something that you basically run from the command line and give you access to the compute node or the GPU node, or the batch mode. You submit a job script and then it runs, and then you can check it. Sometimes if you're using, for example, Jupyter Notebook, you can log in into it, run interactively with it. But usually the batch mode is for high performance things that are going to run, like you're asking for 600 different CPUs, and it's just going into a parallel mode and running at the same time. Now, let's talk about the basic job script. This is the language that Slurm talks. You need a hashtag sbatch to say, okay, I want this identifier for my job name. I need one task. Maybe you're running one program, or you have 64 different tasks that you have to run in parallel, and so on and so forth. How many GPUs per task you can specify. In Shaheen, for example, you can go even further to specify, I want one socket and 16 CPUs doing this task and another task with the other socket. You can go very deep into what details you want. But the main ones are your job name, the number of tasks, if you want a GPU or not. For this example has the GPU there. And then after that, then you start telling like what I want. In this example, you want to load the machine model, the machine learning module that we have inside Ibex. Which, by the way, what are modules? Modules are programs that we already, as a team, have prepared for you to use, that you can load, so you don't need to reload stuff. But you know, there are programs that many users use. For example, the machine learning module is something that pretty much gives you the basic stuff for you to do machine learning in GPUs or CPUs, but you might need to require to do your own thing. And then, of course, in the bottom, you can run your program with srun. So these programs, these little programs are submitted using sbatch, which is the command that basically tells the supercomputer, hey, I want these resources. This is my script. Please run it. And then you get basically an allocation. You have to wait for some time because you are many users. So the resources are shared, and on time, they will give it to you. You will see your job status using SQ, and you will find, usually the first thing you will find is pending, because of course, it's like, we need some slot for you to put, and the queue is complete. Okay, so it's going to be run. But in general, the shortest jobs run faster, just because if you asking for 3 days of running something, it's not the same as another user asking for 15 minutes, right? So the 15 minutes gets a little bit priority just because it runs super fast. And also the amount of CPUs that you are asking might influence that. If you are asking for half Shaheen, it's not the same as just one compute node, right? So there is that. And then this is what is interesting. There are ways you can actually ask for something that is called interactive session. That interactive session can be called using salloc, and it will actually let you interact with the compute node directly. For example, if I go back to this part here, I'm going to cheat a little bit because I had it prepared. I am here in Shaheen. If I run this salloc, this command, it's a very short command. If you see, I specify my project, a time, and how many nodes I want. They grant me an allocation, and now I pass from this login node to a gateway node. All right. So here I can basically do something like usually is tinkering with my program. Like I want it to run very easily. Or in the case of Ibex, you can do srun, and then you ask for a very specific GPU, and you say, okay, I want this memory constraint, and you can see here that I pass from the login node to a GPU. And here, NVIDIA SMI will tell me that I am inside with this memory and so on and so forth. This is something that it can help you to basically run something very easily and tinkering with your program just to do some trial and testing, okay? Now I will relinquish anything, but this is part of the idea. Now yes. Okay, interactive mode is not meant to be for days. That will be actually a batch job. And second is like, usually you don't need to run this interactive mode for too many times because it's in theory for you to do just some testing. So I have heard that some users have to do the interactive mode because they don't know about the batch mode. Okay, but if you want to run a program for several days, then you use the batch mode. The interactive mode is for you to deploy something very easily and test it very quickly. I mean, who wants to be in front of the computer 3 days? Because once you log out from this or your computer goes to sleep, it kills the interactive session. And if you have to run still several hours your program, it's going to get killed and you have to start over. Sort of. All right. So make the assumption that these two have different ideas. Okay. One more thing, for example, if I go to, okay, in Shaheen, for example, you have Scratch and then user. And then here you can do touch this. And it generates something called touch. Sorry, this. Okay. If you go to projects during your allocation, project, user, wait. This is my project and this is my user. Then you try to do the same thing and you cannot touch this, pun intended. So the thing is, like in Shaheen, projects is when you ask for an interactive allocation or a bash script, you cannot write in projects, neither in home. Your home actually is not the home you have because it also protects home. That means that you cannot write or read from your home. You can read from your projects directory, and you can write and read in your Scratch directory. Okay, this is something that is not implemented on Ibex, which is something also beneficial, but be careful, where are you putting your stuff? Okay, because many people try to write stuff in projects, and then it's like, where's my output? There's no output because you cannot write there. Okay. Anyway, moving on. Okay, that's the salloc command. And then you have seen also srun. With srun, you can, I use srun for Ibex and salloc for Shaheen, so I don't get confused, but you can use both in actually both systems. Anyway, the thing with srun, for example, is that you have to specify, for example, how many GPUs. They upset this kind of directives that you can also put in your batch script. It's something that is common because it's the Slurm language. It's what actually allows you to interact with the computer. Okay, what happened when I run something and I just want to kill it because I forgot to put some print or I forgot to put, to generate some checkpoint or whatever? You can cancel. So in that case, cancel also is prone to use, you can use cancel my job ID, cancel my user. It's going to be something that you can actually use. You can see here, cancel this number is going to basically cancel that job there. Again, you cannot cancel other users' jobs, okay? This is for you. Okay, so exercise 2 for Shaheen users. Now that you are there in your, please copy the installation folder in your Scratch. Then try to copy this, this thing here, this task.py program to a Scratch user, and so on and so forth. Try to create a content environment. You can actually try to do the same, Ibex users.
So for Ibex users, you will basically start from ask for an interactive session, right? And drop the -a bit because that is basically the project on Shaheen, if you have one. If you don't have one on Ibex, so drop that bit and put the time, the nodes in it, maybe the number of tasks. How many tasks do you expect?
Yes, 4.
Okay, so one additional bit for Ibex user minus small n4, right? At the end of minus node equals 1, and then minus n4. That will give you 4 cores on one, okay? And the rest applies to you. Source, set environment, the one that you just installed, the contact one, and that will give you the Python that you require. Yeah, don't do that. No, it's not working.
Okay.
Point where we should change. You said you should add minus.
Where was the
Is it? Yes.
Okay, so you have
it says granted, right? Then you grant see that granted is so one quick one. The last line, run the script. Whether you are on Shaheen or Ibex, prepend SRAM. Okay, that's an important one, right? With Shaheen on the prompt, you will see gateway node, right? You are not supposed to run something on gateway node, so I think add SRAM on it, and that will run the Python script on the allocated node. And same goes for Ibex. Okay, so install it. So, Didier, is Dust underscore CPU .py going to run pip install Dust network? So where does the Dust come from?
From the installation.
Okay, so if you ran the conda environment as installation using Didier's script, then Dask will be installed, right?
Yep.
If not, then you can pip install Dask here. I think it's better to run them through this exercise on your terminal.
Okay.
But it's
That's strange. Ah, of course. Yes.
Oh, that's right.
On what?
Mm.
Okay, I'm going to Shaheen.
We do on Shine or Ibex?
No, it's this one was meant for Shaheen, for example. So
Oh, this is for Shine.
yeah,
Everybody's doing this. Okay.
yeah, they should be doing this. So for example, this is not. So if I go my projects. Okay. What? Okay, 1, 0, 2, 3. Okay, I'm here. So in this one, so if you run slog here, you are in this place here, correct? Now, like I told you, you cannot write here because it's a read-only system. What I want you to do or wanted to do, it was copy the install Miniconda. Let's go one up. Copy install Miniconda Shaheen into Scratch /user. And this should trigger the copy command. Okay. Now I'm going to cheat because I already did that. So we left this for here. And I go to Scratch directly. Now here in the let's remove these here. What is it? Ah, interesting. Projects. Okay, then user. It should be quick. Put this here. Over here. Oh no. Right. I remember. Now I can copy this here. Where is it? Okay. Copy. Dash CPU. .py. Into Scratch. User. That's okay. Now I should be able to source this environment. Okay. So in theory, whenever it's ready, you can do source set environment, and it will activate a conda environment that is going all the way from your project directory And then you have a different kind of Python here. Okay, it's one of the latest Python, is Python 3.7, 3.10, sorry. Now, if everything runs correctly, you can run this one in a manner okay. So even for Shaheen or for Ibex, whenever you activate a Conda environment after installing Miniconda, you should have something this large here that will tell you where is your environment or what did you do with your environment. Because I'm running in an interactive session, I cannot write and I can only read from projects. And then it should run in a bit this Dask example. Now, if I go here, I should do this. So this one is the Dask CPU example. It's calling something called Dask. Dask is a library that allows you to do distributed computing. In this case, it's going to do something that is called grid search. Now, this grid search usually is very slow if you do it in a normal manner, asking for a number of nodes. Of course, the number of nodes that you ask will probably help the more you have. It's going to do 1,000 different samples and then run something that is normally done. This is a normal grid search here. And then it's going to do something using Dask. With Dask, I can tell, you know, I want this number of threads or this number of things and modify the actual waiting time. I had it here. Okay, now that it's run, I have a number of cores that I can identify and I can use. Now, with those CPU nodes, it takes me 4 seconds, but you can say, okay, this is 4 seconds for 1,000 samples. It's not that much. I can wait 4 seconds of my life. But if you have like a 1,000 of thousands, it's going to be an order of magnitude more. And then with Dask, actually it cuts down the time by half. Okay, this is the magic of parallelization. You have a number of certain CPUs and you can do a work basically in a matter of seconds, half of the time. And of course, you can see that my grid search was very successful because this data is basically synthetic and it's just something that it can be easily separated. But this is the gist of the history. You have something that you can use inside of the different models that we have or that you can install, and then it will run super fast according to your settings. Right? Well, live demo, people, always fails. Okay. This doesn't work like this, but okay. Now for Ibex users, if you're in your Ibex, try to do this, go to your data science onboarding JavaScript template folder and do just SBatch basic Slurm. Don't do the reservation DS training. You already cloned this repository. Find these JavaScript templates folder and submit your basic Slurm. Sorry, kidding. To this one? For this one, no. This one is independent. So yeah, if you are in your own terminal here, JavaScripts, templates, you should have basic Slurm there. This is my repo, and then job sleeve, templates, basics learn. You do sbatch, basic. And this should trigger your job there. Now, basics learn is a very easy job script. It has basically a name, a task, a number of CPUs per task. It's asking for one GPU, whatever GPU there is, to run this, loading the machine learning module that is inside the G login. Maybe you should get rid of this guy here. Undo. Okay. Do you have something like this already? If you use SQ minus U user, is it running or is it pending? If you have it pending like this, go inside of the Slurm script and get rid of this constraint here.
Which constraint?
There was a constraint here, the A100. Okay, yeah. Yes.
I opened it.
How?
This in the basic, but
Uh-huh.
the basic is learned. Now how can I go back?
Oh no, you did it with BI? Okay. So yeah, I like BI because it's very powerful, but not any. Usually this is one of the tasks. Do Alt double point Q. It should trigger this thing in the bottom. So yeah, be careful with your choice. But then, okay. So in this example, this one run, which is the one without the constraint, because for you to ask for one A100, you need to add another directive that is called reservation. But in this case, we don't need it. It's just to run it completely overload. And you should have something like this, slurm out. And this slurm out should look like this. Now, the first part is basically the machine learning module loading. That's okay. This is something from 2022, from November. And it tells you like, do you have a GPU? Yes. How many? Yes. What are the properties? We have NVIDIA GTX. Okay, nice. With this memory, with this many processors. And these are the architectures that are supported, which are different types of GPUs. And then number of threads, and so on and so forth. This is a very basic example. All right. The trick here was very simple. Get rid of this constraint here. Okay. That's the only thing that is going on right now. Well, okay, for those of you that are not BI native, you can always use Nano. And with Nano, you just need to use the Shift exit to get rid of Shift exit. Come on. Sorry, Control exit. It's Control X. Yes. These editors are tricky. So be careful with which one you choose.
So are we running the first example?
The basic one.
In the basic.slurm, you have this minus constraint equals 800, right?
Yep.
There are some people in the room who might be able to run this, but then there are some for whom the job status is PD, and the reason is the node is under maintenance or under reservation or something.
In this case, reservation.
Okay, at this stage, if you want to run with 800s, you need to be added to a reservation. I would suggest to comment this. To comment this line, you need to use 2 hashes in front of that. So that will go
Like
and
this.
see any GPU that is available and will run this script.
Yep.
Okay.
You either got rid of it or comment it.
So for the job that is pending, just cancel it and submit a new one.
So in this case, I can do cancel. Cancel. If you do cancel /user, you're going to cancel all your jobs. So the alternative is cancel this job ID if you want specifically this one. All right. For those of you that already run the basic one, now try to ask for 2 GPUs instead of 1. The hint is go to the multi-GPU single node slurm that you should find in the same folder. Check it out. Check if you are not asking for A100s and submit it.
Again, the same applies here. Basically, comment the 800 line so that you can run the job. So 800 GPUs are the newest, shiniest ones on Ibex. Actually, they are not shiny now. It's been 1.5 years. So essentially, what they are right now, they have been included in the general queue, and we are slowly and gradually bringing people in. Okay, so if you want to be added to that queue, just email us. Okay. And in due course of time, the reservation will be lifted and they will be business as usual. You don't have to be a special person to.
So yeah, beware of this line constraint. Okay. You can cancel it. I mean, delete it or either change it. You can use B100s. You can leave it without it. And Slurm will assign you some GPU. Nope. Okay.
How many of you have finished that?
One. No, this is Ibex, not Shaheen.
So the expectation of this exercise is the output should give a demonstration that it's running on 2 GPUs, but on the single node, right? The node is the same, but 2 GPUs, and the resources will reflect. And we'll look at the output, try to understand what resources your job actually get.
Yeah. Mine's already running. You just do S batch.
Whose job is pending right now? Everyone.
Everybody's pending. Excellent.
Okay. Right. Business done. Finished. That's it.
Mine is completely done. So now let's put the differential here. Let's see if I can put it here. This is the single, this is the basic, and this is the multiple. Cool.
Right, you see the difference here on the two outputs.
So on your left, you have the result from the basics learned, which was asking for 1 GPU, single node GPU. The right one is the new one, it was the multi-GPU single node. And you can see the difference between the two of them, right? How many GPUs do we have in one? 4. The other one, we asked for 1. That's going to be quite a difference when you try to do something like more into the deep learning side. But now you have the scripts to basically do it. You have the basic structure.
Just a disclaimer, not sure if you run it on Shaheen, what happens? We haven't run this experiment, right? This will probably fail.
It should fail because it's loading the machine learning module that is on GPUs.
So that's the first thing that it will fail on.
The second thing,
it would have failed, even if the machine learning module would be there, is CUDA drivers. So GPUs come with a special driver. Because Shaheen does not have GPUs,
yeah,
surprise, surprise, there is no CUDA driver. And it will basically fail, saying, is there a GPU? No, right? And all the subsequent commands will fail.
Will fail,
They are
yeah.
querying.
GPUs. Okay,
So
they are here in job scripts.
you have a PDF version of slides in your email if you want to copy paste that.
Yep. Then for those of you who are brave enough, you can go and try to do the multi-GPU, multi-nodes learn. Is also there in the templates. You can just check it out, check if you're not asking for A100s, and then just submit it and check it out. So it does look like this. P100 is what we're asking for in this case. You can get rid of that line of constraint or not, depends on your taste. Okay. Let's see, I think it failed. Oh no, it didn't. Nice. So let's compare this again. Oh, okay. So this one, the most right one, this is the multi-GPU, multi-node. I already run that one. The other two are the single node multi-GPU and the single GPU, single node. Now, this one here, you have several lines because now you have multiple GPUs on multiple nodes. This is why the index you see on the right, 0, 1, 3, 2. Now remember, Python always starts from 0. So this is why the identifier is 0. I guess CUDA also.
Yes.
It's always starting from 0. So your first GPU is 0. Do you have a GPU? Yes. How many do you have? 4. But then again, do you have a GPU here? Yes. How many do you have? 4. Because it's calling different nodes and different GPUs. You should have something pretty similar to this one, if not the same thing. But this is why you cannot see the difference. Okay, let's put it just with one guy. Oh. So this part here is pretty much the same, but as you can see in the multi-GPU, multi-node, it has a very different output because it's repeated several times. All right, so it's time for a break. I know you're tired, confused. You find yourself, you love yourself. Yeah, I know Ibex is tired. So just a reminder, you have different logins. You have a login for CPUs, a login for GPUs. Shaheen has one login. Then you can use quota to see how many files do you have or whatever. So now go outside, refresh yourselves because something is coming. It's going to be tiring as well. Yes.
While you're allocating resources and you with a constraint, let's say 10 gigabytes. What does that exactly mean? Usually what I use Ibex for is to run jobs in PyTorch. So using PyTorch. So I'm not too sure. Like, for example, if I have a large batch size, I think the constraint will be in the GPU, not in this 10 gigabytes, right?
No, I mean, if you want to run PyTorch,
Okay.
are you running PyTorch in one GPU, for example? Or you just want to enlarge the batch size?
Yeah, actually, now I'm running in one GPU. What I want to do in the future to run it in multi-nodes.
Multi-nodes,
single
okay.
machine, then the definition and so on. But I mean, like for the time being, my question is like for a single GPU, like what I understand that the GPU has limited memory, and if you exceed if you increase the size of the batch size,
It
then it will not fit
fit
inside the
memory. Yes.
yeah. So this 10 gigabytes that I'm putting as a constraint, what exactly is it? I don't get it.
Okay. So the constraint is on the CPU side, if I recall correctly. Maybe Mohsin can correct me on that one. But the memory side, remember that you have a GPU and then you have CPUs around it, right?
Okay.
So the GPU already have a set memory, but they are talking to the CPUs always.
Okay. Yeah.
So if I am correct, the constraint of the memory goes around the CPU side because you can have different combinations of CPU GPU.
Okay.
There is one that is very specific for example, the A100s work, I think, better with Intel Cascade Lake.
Listen,
Intel Cascade Lake.
what does work better with?
I think is the A100s.
Ah, okay,
Yeah.
the GPU type. Ah, okay.
Yeah, if we go back to this slide here, it's all the way back here. Okay, so here is
Yeah.
better. So if I am correct, the memory constraint goes on to this part here, because we have A and B, for example. A and B, not and then with the memory is going to be basically constrained on what this A and B can do. So then I think the GPU memory is fixed. So the constraint that you put in the map goes over these values.
If I understand correctly, the batch size of the software amount eventually the type of the GPU, which I would the whole data set that I'm training on. For example, it's 9 gigabytes. I should do the constraint of 9 gigabytes, and it's larger than let's say 503 gigabytes. I will not be able to run this job on this CPU, right? Because the data set is already full out.
I mean, you get
Even if the batch size is.
That's the thing, right? We can batch size of different, because in theory you have to batch different with different pieces, okay? Not different epochs, in order to run on the rate several times. So that batch size, what you have to do is to scale the number of epochs. Even if you have size of block.
No.
No, let's say standard. You want more epochs, in theory, you have to batch to days. The probability that batch to all the rest of the three. That one, and that is supposed to be the closer balance to item package memory. Now, the bigger the batch, the more memory you use. And then you are constrained by the. You are using like lab. So you're not getting rid of the batch itself. With a black program out there, you're not storing anything. We can actually look at the memory. Yeah.
It's just we will load batch by batch until we go through the whole state. Then we'll repeat again for the second. How hard is it?
No, I mean, if I remember correctly, it was like this, like the batch itself, it represents one part of the data. But I mean, you want, but you haven't, which is your case, like you're correct, the batch. You have the data set divided in batches, so it fits to the GPU. In theory, the learning algorithm, the bigger the batch size for the learning algorithm, the better, because it learns more. Yeah, in theory, right? Yeah. Maybe I am forgetting or not updated on that one, because if I understand that the batch is just one pass over the data set, and then the echo goes over other batch and it reads, but maybe I'm wrong.
Let's say that we given set has 1,000 the size that size is 1,000. So we will probably spin the
Batches, yeah.
the first of all will go to this the first batch will go to the GPU, then it will be the second batch and so on until we go all of it, and then there's one. Yes, I did the second will the rest of it. So that's why I didn't see a relationship because up to now, so I understand what when I put a constraint, whatever the size is. It's a good.
No, I mean You have to think that the database is going to be sitting in the memory of the CPUs first before it fits into the GPU. So this is why that constraint of the memory is on the CPUs. It will allow you to load the data there, and then you will start, the GPUs will start asking for the CPUs to keep the information there. How much of that information passes to the GPU? I think that you maximize use this kind of thinking. But I'm not sure. Yeah. All right. It goes along that way. This is like, sorry for confusion. Yeah, the memory itself is on the CPU side, so you can load something.
So I cannot ask for more than 500 people, right?
Yeah.
If I want this GPU, I can't ask for more than this.
Yeah, because the other ones that have high memory are just CPU.
And these 1,000 images will be stored inside.
The CPU first. But yeah, you can play around in it anyway. Like use like a very large portion of your database and test different batch sizes and see which one fits better. Not that you just do the quick test. Yeah, I mean, this is why I like playing around, like ask for these kind of resources, like for one GPU, and then max out whatever you can ask about, and then like test different batch sizes. Like one doesn't take for one GPU.
This comes to another question. I tried to compare two GPUs that are offering in the internet, but I wanted to see which one is faster and right. What are the metrics that you use to say this video is this one?
Oh, in this table, for example, is the time.
Huh?
Like in this table, for example, is the time. Like Pascal, really old. Like they are.
I guess I want all GPUs, not just GPUs.
No, doesn't matter very much. Yeah, no, I mean, it has been an evolution with history of why GPUs became important. Because the first GPUs, you're probably too young to remember. Like the first GPUs were for gaming.
Yes.
And it's a gaming device. So there was no computation of deep learning behind. You just wanted better graphics for your game, Doom or something. And then it was just fun. People started realizing, hey, I can upload things onto that thing to the GPU and make things faster. And then they started doing architectures like the Pascal. And before that, there were other models that doesn't run Kubernetes. Now, Pascal is one of the oldest here. But then they started developing really things for deep learning. And then it's like, okay, now you have CUDA and GPU. And the CUDA goes evolving alongside with the architecture of the GPU. So at some point, the Pascal are not going to be able to support the next CUDA iteration. They become obsolete. Like A100s, for example, they can support the newest CUDA and the last oldest CUDA. But there are some GPUs that cannot even run CUDA 11 or CUDA 10. So it's a combination between the software and the hardware. So yeah, no, go ahead.
So the method is decide that what the method is decided and that's the other interest. So now what I'm saying is what kind of code is
Yeah,
so
out of the boxes. Because, for example, the A100s were designed specifically to make matrix multiplication faster. So the design is not for gaming, but it's for running Pascal games. So this is the thing. Like, if you want one of these for gaming, like the best gaming device doesn't have A100s, they have another kind of GPUs. And then the big one for the ones that I know that people actually for gaming and for computing. Now,
so that's
yeah, I mean NVIDIA became rich because people started to invest in these things, like mining Bitcoin or whatever, because the calculations were faster than the CPU. But the origin of this is game. So it was like how cool or how real it looks in my computer, right? And yeah, but from this one, for example, the GTX is kind of old, but still very reliable. I still know some desktops that have GTX and they are very reliable as a GTX. Yeah, they're very reliable still. Like if you want a not like a if you want like a little push over the side of the training, they want to have supposed to be better than that. For testing, GTX is not sufficient for them. We just run something in GTX now, like one of the basic stuff. I took out the constraint and it was by default was GTX, and it was running the Python with the machine learning with Python constraint. So I mean, they are reliable. They're very reliable.
Yeah.
But if you come to the point that like I need to test this in a large data set in a matter of time, maybe you need the
We can find the module, machine learning module. I still don't understand what's different. Like it's a module, machine learning, and imports of it, for example.
oh,
So
okay.
what's the difference?
Okay, check this out. So when we say module, this is Ibex.
So what did you type? C?
No, but you have to type clear
Ah,
and it will clear your window. I just have it like, oh, here.
okay.
Let's wait from here. Module about will give you the list of different software that is loaded into Ibex or into
Okay.
Shaheen.
Okay.
The same for module about. Okay, so you have many things here. You have your CUDA, you have Julia, Java, so you don't have to install it. It's already on the machine itself.
Okay, so say like packages like NumPy, PyTorch, and so on.
Yeah. So for example, we compile the module, the machine learning module. Module load. Machine learning. You have actually different versions of the machine learning module.
Okay.
All ones, this is the latest one,
Mhm.
which is the default one. And then here you already have import torch.
Okay.
And it will load torch. You can, it's already something that we already prepared for you.
So instead of going to my Conda environment and
Yep.
type one by one, install one by one, all of them, if
Is
you just
already-
write
yeah.
module, all of them will be.
Yeah, as a matter of fact, this is this is the idea. We provide you with all of this. This is a basic machine learning packages, but it has PyTorch, it has TensorFlow, JAX, NumPy, Dask.
And if the package that if I don't, the package that I need is not there, I have two options, either to manually install it or to also load another module that you.
Yeah,
So I can
You can combine-
install many modules. Sorry,
You
I can call many modules.
yes, you can call many modules at the same time. As a matter of fact, we will see in a minute if it works again. Where is it? I think it's here. Let me check. In this guy here, you will see that we are loading two modules in Shaheen. Like here,
Modules.
you have two modules. You can load Intel Python and PyTorch.
And
And
what
they work together.
and what if one of the modules, let's say, has a PyTorch old version,
Mhm.
the other one has a PyTorch with a new version? So my code, which one will it use?
In theory, it will use the last you load,
Uh-huh.
but I bet that it will cause some problem.
Okay.
In theory, if you load the last module that you load is the one that goes into your path and is the one that calls is the one that is get called by the machine.
Okay. So I should always put this in mind if I will.
Yeah. It can happen.
Sometimes it has some,
It
you
ha-
know what the problem is.
It will have conflicts. Yes, it will have conflicts for sure. But yeah, you can load the modules you need.
Mm.
It doesn't have to be just one module. You have different modules here. I don't know. Sometimes you will need probably an Intel version, or you need Java, you need Julian, then both things can be called. You need for some different combinations is normal. You have the GCC, maybe you need a compiler from here, or you need another compiler, then you can call them together. The machine learning module, for example, it calls also different things that is going to use. For example, it loads the CUDA DNN,
Mhm.
and also, where is it? Loading, it loads CUDA, it loads OpenMPI,
Mhm.
QDNN, and the GCC 9.2, for example, to work with them. In the next iteration, I'm going to get rid of this. So it just loads one CUDA and that's it.
Oh, okay. You mean in the next step?
Yeah. We have the, wait,
Are we halfway through?
easily, yeah.
Okay.
I mean, okay. So get ready for another piece of advice, but this should actually work, I think. So for you that you want to develop code, you know that you need some kind of development environment, correct? Many people use it. And for data science, there is like the premium one, which is the Jupyter Lab, which uses Jupyter notebooks, which are perfect tools just for scribbling, for testing, and going step by step over your different scripts. And there is a way to do this in Ibex and in Shaheen. For example, you can go into, now that you have the GitHub repository, there is a launch Jupyter server folder. Go into that folder and you will find a launch Jupyter server S-batch. Okay. You have a version for Shaheen and you have a version for Ibex. You can change the memory, change the partition, or change your project, for example. And then you can launch it. But first, you have to be aware, wherever you launch the S-batch is whatever you're going to see in the IDE, meaning that if you are not one folder up, you will see only whatever is in the folder you are launching. Okay, so I'll do that with you. So right now, you are probably inside of jobs templates. You can go to up. Now here, there is this guy here. And you should have this guy here. Launch Jupyter server S-batch. Okay, it looks like this. You can see here the word reservation. This is what we were telling you later, like if you need access to A100s, you probably need this constraint. You can get rid of it, or you can just get rid of it. So you go one up, you copy from launch, Jupyter server S batch. If I correct, yours looks like this. It has 30 minutes, one node. I'm asking one GPU, one by P100. I'm going to get rid of this. The memory is an overkill. So probably I will just put 16. And let's see what comes about. Okay. So this is going to load again the machine learning module. It's going to give you at the end some instructions that you can use. Okay, now it's running. Now here comes the difficult part. You have an R file there. Yes.
I don't think I have the version to copy.
It should be the version to the same as I updated this one. So do you have these texts over there? Not this one? Oh, dang.
Is that the only thing?
The SBatch commands are different. So do you have this one? Do you have this one?
Okay, is that the one? Okay, so the first thing, yeah, so do change 800 to
B100, I'll take it out.
take it out maybe, and just keep it at one.
Yeah, like this.
So I know Didier has commented quite a lot in there, and this is a brilliant script actually. Don't get scared of the script. It's too long and too much in there. What it is, that's a boilerplate. It will remain pretty much the same, minus the hash sbatch thing. You're getting familiar with the hash sbatch thing. That's a resource request, whatever you want, and the rest remains the same. So there is a kind of a template that you can keep on copying.
Okay. So let's work with this one. Let's copy this guy. Outside. And you will need to copy also the one that is S1 outside. Okay. Now SBatch. Well, yeah. Let's cancel all my jobs. And then let's launch this guy here. Okay, it's pending. Meanwhile, let's see this guy here. So if this is correct, still, you're going to load the machine learning module. It's going to give you some directive to create a tunneling, or what you need to start your Jupyter notebook. It failed. Cancelled. That's all.
What was the error?
This is not an error. Clone. Just cut. Yeah. There is nothing wrong here, right? No, wait. Okay, I know. I commented the name. Yeah, reservation needs to go.
The same on the GitHub, is it?
Yeah, I should have. I swear that I upload the new one. Okay. So now you have some error file here that is going to deploy some stuff. Okay. To connect to your compute node, you have to copy paste this part here. Okay. Into a new window. You will have to put again your password. It's going to give you something. Okay. So that will update the error file. Okay. So now it triggered the Jupyter notebook into this HTTP series here. Now let's just copy paste this one into your preferred web browser and give it some time. It should load the Jupyter notebook. Well, Jupyter Lab. Okay, here it is. Connecting. I guess it's being overloaded because we are many trying. Yeah, clear workspace, no problem. All right, here it is. You see, this is important. I told you to copy one folder up because if not, you are not going to see here on your left the notebook folder, the job script, and all the other parts that you have here. All right. So for Shaheen is actually pretty similar. This is the job script for Shaheen. And you will see that you have here to swap something. Is the programming environment. And we're going to actually use another modules, 2 of them. But if you do that, as batch. All right, my bad. Actually, because I am launching it from projects, isn't going to write nothing because projects is read only. So if I go to Scratch, should be another story. Copy from projects. Let's just do this. I'm going to submit this one here. It will create something. Okay, let's give it a minute. And the same applies here. You see, it's going to tell me just put something into a new terminal. This here. This creates the first step. You input again your password. And then again, your one-time password. Where is it? Oh, here it is. Yes, I know it's a little bit different, but we are secure. Okay. Now, the difference between Ibex and Shaheen is that Shaheen actually asks us for a second step where you have to do this command to connect to the actual node that allows us to go into the interactive mode. That's going to deploy also the Jupyter notebook. Give it a time. Okay, going to take a while. Anyway. So let's go back to the presentation. All right. So as you see, the Jupyter launch, it has basically two parts where you have how do you connect with, how to talk with Slurm, and then a sort of different directives that allow you to connect using a SSH tunneling. That means like it's going, your connection is going from directly the compute node to your laptop, okay, which is this part on the right. And you see it's very easy to follow. Actually, you just copy paste whatever it comes out of the Jupyter notebook, input into the web browser. Now that you have does everybody have like a Jupyter lab running? Not yet. Ah, okay. This one, if you copy the data science onboarding, it should be in launch Jupyter server. And I have several here, but there is this launch Jupyter server folder. You should have something like data science onboarding, launch Jupyter server. Yes. Launch Jupyter's server. Is the dot, you have to copy paste, in this case, two of them, the S batch and the S run.
So there are two scripts, okay? The S batch is what you use to submit the job, and that Slurm script is going to call on this launch minus Jupyter minus server.h1, okay? Now, this needs to be executable. So when you're copying it, just do ls minus L on it. See if there is an X at the end of the directory side that it is executable. If you have coloring in your terminal, that would be.
Yeah. You have this X over here.
Yeah, I can see smoke coming out of that. What do you do?
Okay. This is a Jupyter notebook from Shaheen. We can do the same here. Hopefully it doesn't crash. Okay. So after you copy those things up, you should have them here, one folder up. Then after you change this line, the line of reservation has to be either deleted or commented. Also, I changed the line of GPUs per node. In order to have just one, that line over there. That's to comment it. That will silence it. Either you delete it or you do this, and then it will not read it. Sloan will not read it. It will think it's a comment. No, it will generate air file and out file. You have to do now the launch of that. You do this. Okay. And then you check this file here, the air file that it generates. In that air file, the first thing you will find is these commands here. You copy paste those commands into a new terminal. Okay, now for those of you that already have the Jupyter notebook, the Jupyter lab up and running, go into notebooks and you can start with introduction to linear regression using QML. It's a nice exercise that it will introduce you to how to use a very specific library called QML, which allows CUDA to basically do machine learning. Now, one thing that I'd like to mention is that if you go to this button here, it says GPU dashboard. Should deploy something here soon. Just along the lines of this guy here. Okay, that's it. Manager, Git, Pulse, Dask. That's all. All right. Oh, my MV dashboard is down. Right. All right. So if you were able to run your Jupyter lab, you can start with this introduction. I'm going to showcase something that I like to show, which is the Dask QDF, which is basically inputting the information into the GPU, and you will gain actually a lot of time. So with the machine learning model, you can start here loading whatever library you want. Then this step is going to actually query something from outside and download a data set that is 4 million rows with 5 different columns. I already have it, so it's not going to take that long. But then I just close this one. So here I already run this. Usually for any data science work, you will use pandas. Pandas will allow you to manipulate a lot of different, especially as comma separated values. And you can see that reading something that is 4 million rows in pandas take about, I don't know, 11 microseconds. Nice. If you use QDF, it's going to load it into the GPU, and it's going to take half of that time, which is nice, actually. You are again halving the time that you have to wait to get something done. From there, it just gets more fun, because now you can input it into something that is going to be a distributed version of that is going to use all the GPUs or all the CPUs using Dask, which is, again, a library that allows you to do distributed computing. And then so on and so forth. You can convert that into this distributed part. We're here querying just the system using this Jupyter magic, as always. And then with this magic of Jupyter, the time, this kind of operation that takes with pandas several minutes, it will reduce to literally seconds. This is because everything is input inside of the GPU. So for example, this is already done here. Nice. Let's trigger this here. Again. Now, it might seem that this already was read. It was already read. And we are taking too much time here, but this is just apparent because this is an interactive session. The GPU is going to show that the actual use of the time of the computing time is half, I hope. Yes. You have to go to notebooks folder. If you succeeded in launching this thing, go into notebooks. In notebooks, you have different notebooks that you can explore. Introduction to linear regression is here. You see? If I input things into, it's even better than expected. This is normal pandas. It takes 33 microseconds. Nice. When I tell him, load this information into CUDA, it takes about 10 seconds less. And if I do the distributed version, it really goes down to 8.11 microseconds. So this is time that you are saving. You're going to input all your data into something that's going to actually communicate more quick than normal. By the way, what am I running? The other one was in a Volta. I have the same. Curious. Nice. 22 seconds. Okay, nice. So this one is something that you can do in your own time because it has different different, what's the name, windows that you can actually deploy. Over here is one of those examples, like you have the solution here in case you get like lost. And of course, we can run something like torch test because this is a machine learning module. We can load it. And this is the basic Slurm that we already run. There you go. So you can start doing your scripts as a Jupyter notebook inside Ibex in a compute node, in a GPU compute node. And let's say you want more. Okay, you also have here your terminal. So you are not exiting the system. You are just playing around. And you can go to home. If in case you forget something. But well, this is the power of Jupyter Lab. Basically, you have access to this, and this is a way to deploy it. We have a new version of how to deploy this, which is one concise script, but the steps are the same. You copy paste an SSH tunneling, and then you copy paste something into your browser. Well,
But if I want to use another library,
you can.
for the terminal in the
That's a very good question. Why don't you? When did you try? So you have the term. I mean, all the modules are. If you kind of install things in your home, it will be there. Like if you use, for example, pip, and you redirect your PNF installation to save your library into a folder in your home, it can load it again. And of course, like I said, machine learning module is something that is kind of basic. It gives you the starting point, but if you want something more tuned into what you want to do, then you probably need to do a virtual environment or use a container even. It depends on what you want to do, what flavor do you like. All right. All right, let's jump into another IDE. We can talk later. Don't worry. Anyway, so there is another thing that you probably heard about, which is VS Code. VS Code is a very powerful tool right now. Very powerful tool because it allows you a lot of different packages to be managed. But the most important thing is like it also allows you entering the GitHub Copilot program, which is very interesting. So to launch it is pretty similar to what you did. It's actually a little bit more simpler just because it comes load again into the machine learning module. You can install it in your Conda environment or even install it as a standalone thing in your home and then call it. Okay. We already have for you one of these one of these batch jobs that can run the Jupyter server and code the code server launch, which is pretty much the same. You can see you have your Slurm directives, and then a bunch of things that are going to give you the tunneling. So for this exercise, let's try to run code server. Okay. Okay, for code server, let me just kill whatever I have. Do I have something running? Yes. Okay. Let's kill it with love. Okay. So here, you should have also in the repo something that is called launch code server. Is that correct? Did you know about code server?
So this is another interactive development environment, very popular in data science world for some reason. I don't know why.
Oh, I know why.
Oh, you know why.
I know why. So for example, let me know, does it look like this? Did you find it?
Yes.
Launch code server for Ibex.
Is this the same file that you see on your repository?
Yes, okay, so
Okay.
Okay.
One validation is enough, I guess.
Yes. Okay, let me just change the time to this one. So copy again, launch server one folder up, and then do the S batch and launch it. Okay. It should again start giving you something, an error file and an out file. So in the error file, we have the instructions. Again, very simple instruction. Copy this line to create the tunneling. Let's go to here. Oh, I killed the job. So this guy is done for. There you go. Okay, this guy is done. Now, oh, not here, sorry. You open a new window. You put, copy paste that. Input your password. Get denied. Input again. Get inside. Okay. The tunneling is set. So you just have to copy paste this thing here into your browser. Then it will start talking to the compute node. And it should look like this. It will tell you, do you trust yourself? Sometimes. Okay. And it should look like this. Correct? Again, you do the S batch for the code server, S batch. Okay. It will give you an error file and an output file. Check the output file. Okay. In the output file, you will find an SSH that is going to create the tunneling. Copy that line, open a new terminal, paste it, and log in. Not this one, the SSH. Okay, once that's done, you already log in, you put your password, copy paste this thing here, localhost, into a new window. It should start and then look like this. Now the fun part of this looks like VS Code, but it's actually an open source project called Code Server. The thing here is that it has something that's called extensions. Now, with extensions, you will have to install something, like for example, the Python extension, you have to install it because it doesn't come by default with it. You can also get access to something cool like GitHub Copilot. In that sense, it also gives you all the different tools to create a demo. .py, for example. And then you can tell, oh, you have to log into GitHub Copilot, for example.
And it gives you a terminal as well, right?
It gives you a terminal as well. Okay. You authorize. Excellent. Now, if I recall correctly, here is the terminal. You can create a new terminal down here. Then who am I? Let's put this a bit bigger. There you go. This is the same thing. Now with GitHub Copilot, you can do something like create a class. It's a little bit shy, doesn't want to work. Yeah. Okay, doesn't want to work. Good Copilot. Anyway, so in this case, for example, you're already here. You can go inside different folders. Python load C4, for example. This load C4 example here actually is something that goes into Ibex reference folder. Check the C4 standards here. And because we are inside of our environment, it's just going to work, okay? You can play around, it's basically the same. You have your Git control here. If you want to have your control, your version control and everything. It's an IDE that is getting popular because it's really flexible. The extensions are the part that is very, very important. For example, Prettier Formatter gives you this colorful outlier. You can use it for your own Jupyter notebooks. More than that, you can create your own cells using this magic. Oh, come here. So when you put hash ampersand, then you can say print hello. Okay, like that. Run this cell, and it runs here, connected to kernel. You see, it automatically loads like a Jupyter notebook style thing that you can use to play around and troubleshoot things. Okay, this is actually why it's becoming also very famous, because you can turn your normal scripts into Jupyter notebooks right off the gate. And if you can use Copilot, it will be great. But now Copilot is just denying me for some reason. Thank you, Copilot. Anyway, so there is that. Now, why don't you go and try again to run, for example, torch test? You see, there is torch test here. We can close this. Clear here. The nice thing about the Jupyter notebooks here in Code Server is that it gives you by default the time it takes to load something or to do something, gives you exactly the same result because it's a Jupyter notebook. But it looks a little bit cooler or nicer, maybe. And so on and so forth. Okay. Right. Any question about the Code Server? Whatever you prefer, Jupyter Lab or Code Server, they both let you work inside of the GPU node, for example, or compute node. All right. Let's move on to close this session. Okay. Have you ever heard about containers? Some have, right? Okay, nice.
Are you guys interested in?
Yes.
Yes. Okay, that's
Okay. If you want to, I don't know what we do because
Let's finish.
okay.
Let's help her with this slide.
Let's remember there is a special session of containers. One more news.
Oh yeah, so 1st of March, I'm running a training on containers. But here we are talking about GPU enabled containers. We are an NVIDIA shop. So NVIDIA has a NVIDIA GPU container repository or registry. So how many of you actually know about containers, what containers are? All right. So essentially what containers are, and I saw half a hand there. That's okay, right. So essentially what containers are basically, they are an encapsulation method which allows you to encapsulate your software platform so you can bring it to other platforms. Like for example, moving between Shaheen and Ibex and your workstation to the cloud and anywhere. What do you exactly need? You need your libraries, your runtime, and your code, right? These three things are what we need. Everything else is in the hardware side. If there is a GPU, there will be a driver on the GPU. Your code is supposed to accept that. The libraries should be enclosed in that environment so that they can talk to those drivers. So what we will concentrate on is how to lock in the software that we do, right? And then probably take it somewhere else. So some of you were actually installing Conda environments. And for some, it was a huge pain because that environment.yaml had the whole kitchen sink, right? It was taking forever. Sometimes the file systems are slow. Sometimes you may or may not have internet access. In those scenarios, containers come in handy because they come batteries included for whatever you want, right? There is an expense to that, and that is you will give away some of your RAM, your memory, when in runtime. So say, for example, if you had 16 gigabytes and your container requires 2, it will take those 2 gigabytes and roll out the file system, right? So that those libraries are there. The other thing is, without the kernel, Linux kernel, it can bring the operating system with it too. So you can be on a, let's say, Windows machine, but you might be running Ubuntu on it within a container. So that's a fascinating scenario, right? So you are Shaheen, on Shaheen. Shaheen uses SUSE Linux. Ibex uses Red Hat's flavor called CentOS, right? Red Hat's open source flavor called CentOS. Those two are different file systems, but the container has Ubuntu in it, for example. So you are still in Ubuntu, and your software is confined from operating system down to the libraries. So that's the whole idea. How do you create containers? Well, you create containers with a recipe, and the recipe is called Docker file. Why is it called Docker file? Because Docker used to be and is the de facto standard for containers, right? Surprise, surprise, we don't like Docker because it does weird things from a security point of view. So what do? We use another kind of container platform which still understands the output of a Docker file. So an output of a Docker file is an image. Okay, it's a compressed consequence of this Docker file. So look at the Docker file. Apart from some keywords, it is pretty much the same as you do on a prompt of Ubuntu. How many of you have used Ubuntu? Right? Oh wow, everyone has, right? So that's the Windows of the Linux world, right? So you have description of some sort. Who do you talk to when things don't work? Run apt-get install blah, and then I am basically creating some directories, installing some HPL source code from source. I intend to put this XHPL in a place where it can execute. That's the containers own /HPL/bin/blah. And when I instantiate a container from this image, whichever will come out of it, when it is built, this command will run by default. I don't need to do this. Okay. So all said and done, what are the steps in there? You need a Docker file. You need a container platform to build that Docker file into an image. That's the thing that you bring from platform to platform. Think of it as a compressed Java, okay, with everything included. You need to push that into something called a registry, where basically it's an archive of images belonging to you and you with tag and so on and so forth. So you can have HPL 2.3, 2.4, 2.5, that's a tag, okay, to identify what is the image and what is the relevance of the image in terms of version. And you can then pull that image from the registry onto another platform. This awfully looks very, very common and similar pattern as you do with files, right? A Google Drive of images, let's put it that way. Okay, so as I mentioned before, what is the motivation of that? You bring your base image, which has all the OS related libraries. Then you bring your system related libraries like the compiler version, and so on and so forth, the GCCs and all that. Then you bring the stuff that your software requires, maybe Apache, maybe something else that your system requires. And then you instantiate a container out when it runs. So in runtime. What are the choices of container platforms? I mentioned Docker. How many of you know about Docker? Okay, there are a few hands there. Okay, so as I mentioned, Docker has been around for quite a long time. and its practices have been somehow accepted as standards as well. These standards are called Open Container Initiative. So at least the image format is Open Container Initiative blessed. So that's the standard, right? So you create that image using a Docker build command, and it should be able, you should be able to work with Podman, Apptainer, which was called Singularity and is called Singularity as well. Saurus is one of our sister organizations, CSCS's product. So there are plenty of them. I'm just naming a few that we like. What you can do with these images is you can build them on your x86 platform that you know and love, but you can use ARM machines as well. So Apple M1 is an example, it's Arch64, but that container image, that image will be containerized on a machine that is ARM as well. So it's an instruction set difference. So you have to probably do that. So why am I mentioning all those things? Because as I mentioned, NVIDIA is doing a lot of stuff in that area, and it is publishing it as container images for x86 and for ARM machines, so that you can have a turnkey solution for the GPUs for some of the common patterns. So here I'm going to do a demo, which will use a PyTorch image from NVIDIA that I have already pulled into a format called a Singularity format, because my container runtime is Singularity on Ibex. And then I'm going to run a multi-GPU Slurm job using that container. There are some instructions on how to pull the image. You need an API key access to the NGC cloud. It's there with the slides if you want to do it later. So I'll probably show rather than talk. Okay, let me minimize this one. Right. I'm going to SSH into glogin node. Going to go to my repository where the code is. Containers. Okay. So this is the Singularity file I was talking about. If you look at the Singularity file itself, it's the image that I was talking about. It's a good 6.3 gig of image, because you remember PyTorch, right? It's a heavy installation. And there is other stuff in there as well. I did not install it. Someone who is much better than me in software has done this thing. I trust them. Let's see what happens. Okay. So the Slurm script looks something like this. So here is a 4 GPU, 1 node. G4 N1 is 4 GPUs, 1 node Slurm script. And I'm sure everyone is an expert here in Slurm now, since we have talked about it so much. So what is it doing? It is asking for 16 CPUs that I'm supposed to use as threads, 4 GPUs, all of them on the same node, right? And 800 constraint of the type 800, and for 5 minutes. Then I load a module called Singularity. As I mentioned, Singularity is the container runtime that we use. And then I set some environment variables in the bash and launch the container in parallel using the srun command and then the Python line. Okay. So all I do is okay. So it looks like I'm running on a wrong node. Excuse me. But it's complaining about Scratch, not mounted. Did I mention data dir? The data is in there. Say it again. Yes. This one? This exists, yes. Bind mounting that. It's this issue. Container failed because it's trying to run on this. Where do I ask it to? Let me see. Okay. So probably it is trying to bind mount Scratch, which it won't find on 800 nodes. So let me change this to RTX 2080. Yeah, V100 nodes have an issue actually. Let's try it. I mean, it's one. So, okay. Dispatch G4. Let's see that. Skins. Okay. So 2, 3, 6, 7. All right, it's starting the training. It queried some things, looked at, and then it started. We asked for 4 GPUs, right? So it has started 4 instances of my Python script, and these nodes have a special interconnect between the GPUs called NVLink, and my script is using a backend called Nickel, which can communicate on that very high-speed interconnect between the GPUs. Why do I need it? For the machine learning, deep learning people here, you may be familiar that you have to move a lot of data between the GPUs on each set. Why? Because what you do is you partition the data into 4 in this situation, put the same model, the same program on each GPU, and then feed different data. But remember that this is the model that needs to see all the data all at the same time, which basically means they need to update their local weights into global weights, right? So the weights need to move from one to the other. Now imagine if there is iteration of batches in the whole data, and you have like thousands of iterations of that in one epoch, and you have hundreds of epochs. That's a lot of data movement between 4 GPUs. It requires a lot of bandwidth, right? This NVLink is very high bandwidth, very low latency fabric, and nickel is going to be used. So PyTorch is supposed to be built with that. NVIDIA did us a favor there. They not only packaged the NVLink and nickel-enabled PyTorch version, but also the MPI with it, which helps distribute stuff, right? And other things that are really necessary. So these containers are a very good way of getting around to prototyping, sandboxing things ab initio, and they are production ready as well most of the time. So you don't need to go out to do things unless your software is changing. So you're experimenting with it. You need this library, that library, that library. So that's where you talk to us how to create your own container, basically. So one of the fun thing is, I won't do that, but you can use base container as NVIDIA's container and then build your own container on top, right? With your own libraries in it. It will grow in size. Remember that. That's the only catch here. So I'll leave it here. Go back to my slides. Where were they? Here. And yeah, so that's where I'll stop. Then we are talking about scale out demos. Should I? Okay. How are we doing on time? Yeah, okay. So I'll try to be concise. You're doing things on one GPU. You are using a model, and basically, I'm taking the example of data science model. You are working with representative data because we are doing a lot of coding. Now is the time to check, right? And I want to train my whole model, my model on a whole data set. Now, somebody here explained to me they had a data set worth 400 gigabytes. Now, the model's pipeline will look something like ingest the data into the data loader, feed the data into batches to the GPU. The GPU churns and then does the compute of weights, updates the weight, does the back propagation, and then off you go to the next batch, right? And you keep on doing that for, I don't know, 100 epochs. This is going to take quite substantial amount of time. We can rethink the problem such that if we had the same model, as I mentioned before, onto multiple GPUs, then we can feed the GPU with different batches such that we can throw more resource, go through the data set in one epoch quickly, and then go to the next epoch. So time to solution or time to training the data set would be down a little bit. So that's the whole idea of how do I go from 1 to n GPUs using data parallel model. So in PyTorch, you have this distributed data parallel or DDP. I'm running a training on 12th of February on this and other frameworks which allow you to do that. This is about how you run this DDP, PyTorch DDP on your Ibex platform. We did that same thing with the containers just a minute ago. Now we are going to see in situ on Ibex, is there a software that we can work with? Then there is another one called Horoward. Horoward understands frameworks like PyTorch, TensorFlow, Keras, and MXNet. So it supports those frameworks, and it allows the framework to be separated from the distribution part, right? The parallel part. So it implements the parallel parts really nicely, and it is used for data parallel training again. What's the motivation behind all that? What do we get after all that effort? There is code refactor involved, obviously, but if you had more resource like Ibex or Shaheen, and big data, then you can start with one GPU. And let's say if you had 32 GPUs, look at the time to solution for 10 epochs. Now you can fail fast and do something different with your model quickly, compared to if you were on the same single GPU, it would take you 10 hours to finish 10 epochs. Is it hours? Yes. Let's say it's hours, right? So you are scaling very nicely. And not only it is GPUs on the same node. Look at the x-axis, it is multiple nodes. So you are actually scaling out to multiple nodes of the same kind of GPUs. Let's put it that way. There are limitations. When you start to keep your data the same amount and throw more resources on it, DL training is not a strong scaling problem, which basically means I'm going to keep my data the same and I'm going to throw more resources and it's going to go fast. No, your batch size has to, global batch size has to increase. So when you are doing that, up to 32 GPUs for my problem, it is pretty okay. The parallel efficiency is pretty okay. And when I talk about parallel efficiency, how efficiently I'm using both my hardware resources and the communication resources between the hardware. Right? So that's the parallel efficiency of the mini batch, large mini batch training. So I keep on increasing the batch. There is a difference between implementing PyTorch DDP in a vanilla manner and then using Horoward instead with the same PyTorch code for the single GPU, right? So if you were working on Horoward instead of PyTorch, for example, on 8 GPUs and on 16 GPUs, you see different benefits of changing the framework. But either way, if you get from one GPU to a code that can run on multiple GPUs, that in itself is a big deal. So I don't think I have enough time for the demo, right? Come for the demo on 12th of February. We'll do a deep dive in how to actually code for this kind of, right? Any questions before we finish off? By the way, the demo also included something called Raytune. I'm going to talk more about Raytune on 13th of February. So these are consecutive trainings, 12th and 13th. Say, for example, you had a single GPU core. I'm just taking an example of single GPU core. But you wanted to run parameters on your model to optimize your model. And you had hundreds of them. So in this scenario, whatever you have learned today, it will imply that you need to have 100 jobs on Ibex. What if 95 of them would fail? So basically, you will spend half of your life optimizing a model, which may or may not be a good model. So there are intelligent ways of doing hyperparameter optimization on your models in a way that we can set search spaces and intelligently move into search space, and maybe early stop onto a bad trial and move on to the next trial, right? So I'm going to demonstrate that, and we're going to deep dive into how to code for that kind of question on 13th of February. All right. So if you are interested, just look at the announcement and register for it.
I was going to upload
Keep your emails to have the PDF, but the recording and the slides will be uploaded on that. Right?
What's the review of 3 months training? You will now one this.
Thank you all. We are here to answer questions if you have any. And thanks everyone to attend on Zoom. The Zoom thing is gone. I'm thinking.
Yeah, it should be here. Should be here.
Thank you all.
Let me just stop sharing.